Hello students, today's agenda is to check homework. We're going to be learning about minimizing cost, and you will be able to do 5.5. Today students will be able to determine an optimal point to minimize cost by applying systems of inequalities. So this is going to be similar to the previous lesson, but instead of maximizing profit, so antes era, la lección anterior es maximizar ganancias, ahora es minimizar costo. Okay, so let's see. And actually, since yesterday we went over a lot of details about the vertices and other points, today it's going to be a lot simpler. Okay, so this is a scenario. It says, imagine that you need to buy at least 6 things for a party. At least 6 things for a party. You need to buy at least 1 pizza and at least 2 watermelons. Okay? And then it says pizza is $8 and watermelons is $5. So that's going to be basically for the cost. And then it says, what amount of pizzas and watermelons should you buy in order to minimize cost? And so we're going to start by creating our inequalities. If you need to buy at least 6 things for the party, and they're talking about pizzas and watermelons, now to begin with, we have to remember what this at least means. At least it means that you need that many or more. Okay? In Spanish we would say por lo menos. If we say por lo menos, that means we need that much and more. Okay? So let me write here the inequalities, and then we'll go with the cost. So I know that it has to be with an equal symbol because it can be that much or more. Okay, so we're gonna put that the pizzas that we get plus the watermelons that we get are going to be more or equal than 6. That's what at least means. Okay, that's for my first inequality right here. Then it says you need to buy at least 1 pizza. Again, that word at least means greater than or equal to. So the pizzas that I get, remember that in the previous lesson we were just saying hamburgers is greater or equal than 0. In here they're telling us at least 1 pizza. So it has to be greater or equal than 1 pizza. My watermelons have to be at least 2 of them. So at least means greater or equal than 2 watermelons. And then this is for our cost equation, because we know exactly how much a pizza costs. We know exactly how much a watermelon costs. Okay, it doesn't say at least or at most or it's greater than. Okay, so that's going to be our equation for the cost. So my cost will be $8 for every pizza plus $5 for every watermelon. And so basically this is it. That's all I have for my inequalities. And remember from previous lesson that the inequalities are used to find the vertices. And with those vertices, we use the equation to figure out which one will give us the lowest cost. Okay, so now that we have our inequalities, let's graph. And so I noticed that this is in standard form, so I'm going to be dividing. I need at least 6 points in here. Oops, keeps sliding on me. And so I'm gonna put this as my pizzas and this as my watermelons. I usually like to keep myself organized with alphabetical order to make it easy for me, but again, if you switch the P and the W, it won't make a difference. It will look different, but once you find the vertices, you will find the same information, okay? So it won't matter. Okay, so it says that P plus W is equals to, greater or equal than 6. Since it's in standard form, I'm gonna use my intercepts. And so, if I decide to get 0 watermelons, that means that my pizzas are going to be 6 of them. If I decide to get 0 pizzas, that means that I'm gonna have to fill my invited people with watermelons only, so it's gonna be 6 of them. Okay, and so that's my first line. Let me put in here 1, 2, 3, 4, 5, 6, and that's all you really need. And then -1, -2. Okay, and so 6, 0, it's right here. 0, 6, it's right here. I see that it's a solid line. And for my shading, I will need a testing point. You know that my favorite is 0, 0 because it helps me eliminate a lot of the work. Why? Because you replace the variables by 0. So 0 pizzas plus 0 watermelons should be greater or equal than 6. 0 plus 0 is greater or equal than 6. Is that true? No. 0, it's actually less than 6, so this is false. Since this is false, this means that this is not a solution. So I'm going to go over to the other side and I'm going to shade the other side of the line. Okay. For P, I'm going to use this color right here. I don't know how it looks in the video, but in here it looks magenta. Okay, so P is greater or equal than 1. So my P is this one right here. That means that I'm gonna cut P at 1. Yeah. Okay. Right there. And so it's a solid line. Whoops, sorry about that. And so my shade says P is greater. Which ones are greater on P? The positives or these 0 and negatives? Well, the positives are bigger, so my shade should go on this side of the line. Okay, notice how I leave a lot of space because I just want to see clearly where they overlap and then go over with more color right there. Now I'm going to use let's see if I can find an orange. There it is. And so now for the watermelons, I'm going to use orange. They look very similar. Maybe I'll use the yellow one. Okay, sorry about that. And so W, which is this right here, is greater or equal than 2. So I'm going to cut this W right where the 2 is. Let me see if I can show on the video. Yeah, I think you can see it pretty well. And so it says greater. Where are the greater in here? Is this greater or this section greater? Well, the positives are greater, so my shade will go up. And so I'm gonna check to see where all three shades meet. And if you notice in here I have only yellow and green. In here I have yellow, green, and pink. In here I only have green and pink only, and then white. Okay, so the limit is right here because you have the pink starting here, so I can see that. Whoops, I'm sorry. I can see that this section right here, limited by this part, it's all yellow, and I'm not gonna color all of it so that you can see also the other colors. Okay, but then the yellow is limited to here. Then you have the the green, which is going this way, but then again this line limits it, right? So it's right here. And then this yellow limits this part, so you shouldn't go below that. And then did the yellow now the pink is right here. Now if we're looking for the vertices only, basically here to maximize and minimize minimize the cost, you can see that it's where the two lines meet. In here is this point, and then where these two lines meet is this point right here. And so what are those points and what do they represent? This point is 1, 5. 1 pizza, 5 watermelons. So let me write that down. That point right there is 1 and 5 for the watermelons. Okay, and this other point is 4 pizzas, right? 4 pizzas. And how many watermelons? I go to the side and it's 2 watermelons. Okay, so which one will give me the lowest cost? Okay, I want to minimize cost, so I want to figure out, and I'm going to be using, if you recall, the equation was cost equals to $8 per pizza plus $5 per watermelon. And so for the first point, let's see, the cost is going to be A multiplied by 1 pizza plus $5 multiplied by the cost of watermelons. And so it's equals to 8 times 1 is 8, 5 times 5 is 25. And so my cost, if I decide to buy 1 pizza and 5 watermelons, it's going to be $33. In here, if I buy 4 pizzas, that will be $8 per pizza times the 4 pizzas plus $5 per watermelon times the 2 watermelons. 4 times 8 is 32. 2 times 5 is 10. And my cost will be $42. So if I need to buy at least 6 things, at least 6 things. Which combination should I use to minimize cost? Well, 33 is cheaper than 42. So of course I will buy one pizza and 5 watermelons to minimize cost. Okay, so again, these maximizing profit and minimizing cost are very similar. The difference is that in here you're checking only 2 points at this for right now, and well, I hope you have fun doing 5.5. Thank you.